Hey guys, welcome back to AlgoYogi. We are now doing stack series and we are still on the easy level problems. Our next problem in the list is minimum string length after removing substrings. So let's go to LeetCode. You are given a string S consisting only of uppercase English letters. You can apply some operations to this string, where in one operation you can remove any occurrence of one of the substrings. What are those substrings? A, B, and C, D from S. Return the minimum possible length of resulting string that you can obtain. Alright, note that string concatenates after removing the substring and could produce new A, B, or C, D substring. That makes perfect sense. I think it's like a really straightforward problem statement. Let's see how we are going to do it. This is the string that is given to us. We need to remove two substrings, A, B, and C, D. These are the two substring that we need to remove. So if we iterate our string over here, then we see one of the occurrences right here. So after we remove this one operation, we will have FCA CDB. Then we see, okay, we now see CD operation, CD substring that we need to remove. So we will remove this. Since it's in our removing substring, that will give us a new substring now. So remember, after we remove these, we concatenate whatever is left. So FCAB. But now again, we're going to do another check. If we have a substring, if this particular string contains another substring that is CD or AB, now we again see AB. So what do? We remove it again, and then whatever is left, concatenate that. So FC. Now we can't find any of the occurrence of AB or CD. So what do? We remove 2 because that's the length of this substring. So now we understand the problem. Let's see how we are going to do it. So brute force approach would be basically what we just did. We go over this string, we remove it, we concatenate everything together, and then try to check again unless we cannot remove it. So that will be a solution of big of n square time complexity, worst case, or maybe better, but I think that's not efficient at all. So what we're going to do is we're going to make use of stack, just like we did in the last problem. We have done that. So what we're going to do is we will have a stack to basically track what have we seen so far. I think that will make our problem really efficient. So we're going to start iterating our characters or English uppercase letters from left to right. So let's say, and we're going to keep appending them right straight away to our stack. So as I'm going forward, I see A, I'm going to append it to my stack, and then I see B, I'm going to append it to my stack again. But there is like just one small case, like now how do we check if we have seen occurrences of A, B, or C, D? How do we check that we have seen these? I think we are going to basically look on top of our stack last 2 characters. So only if the length of stack is greater than or equals to 2 and the last 2 characters, so stack 1, stack basically -2, or we can just append them, stack -1. If they both are equals to AB, or they both are equals to CD, then we're gonna pop both of them. So stack dot pop, just do this operation twice so that we pop both of them out. So pop both of them. If you're seeing, because after you combine them, it will make an occurrence at the substring AB, or there might be another case where you see CD, but we keep doing that. We're gonna keep doing that. So now you can see, let's say this is gone, and now we are already at F. Okay, we're already at F. So these two are gone. So what do? We're gonna keep iterating now. Our stack is empty. So if the stack is empty, then we're gonna start pushing to our stack. So F, then its length is not greater than or equals to 2. We go to C. Now we're gonna check if FC is in this particular substring set. No, it is not. So we're gonna go to A. So we're gonna append A, then C, these two, sorry, not these two, but then we're gonna append D, and these two match with CD over here. So what we'll do, we'll pop up them, both of them. So this is what we will pop off, and after popping these things off, we're gonna append B. But remember, the length is right now stack is greater than or equals to 2. So we're gonna make check of upper topmost two string, combine them together in the right order, fetching the second last one next, and check if they're equals to AB or CD. These two are equal to AB, so we're gonna pop these two off. So these two off are gone, and then you will see that remaining string that we have is C and F. I think this was the best example to show this. So this will be a solution of big of n time complexity, because we are only iterating all the characters once, and then space complexity worst case would also be big of n. All right, I think there are solutions around this problem which uses 2 pointers, and I think this problem could definitely be under 2 pointers category. You have these 2 pointers, and just always move them, keep checking them, keep pushing one to before it. I think there is a way of doing around it, and I think it's quite simple to approach. You can do that, but I'm just gonna, it's an easy problem, so I'm gonna just write this solution and move forward, because it's a efficient solution. At the end of the day, we don't really care about the memory in this scenario. So the other solution will bring down the memory. That will be an in-place solution. Let's write this one. Right, looks pretty good. Okay, so I'll have a stack, as we said. We're gonna have a stack, then we're gonna start iterating over our characters in S. So for C in S, if length of stack is greater than or equals to 2, then what do? We will basically make our string, so character, or let's call it sub str, which will be, let's pop out from stack the last row, second last, and then last. Combine them together and check if sub str equals to AB, or this is equals to CD. So sub str equals to CD. If any of these conditions are true, then we're gonna pop from stack twice, stack.pop, and then stack.pop, stack.pop. Otherwise, I think it's better to basically, even before we check for this condition, let's append it to my stack, because at the end of the day, it's okay, like we have to push things to stack to pop them out, so we can do that right in the beginning as well. Stack.append, let's append C right here, and that's it. Finally, we will return the length of this stack. All right, I'm gonna zoom out. I think this looks like a good solution. I don't see any mistakes. All right, so I'll just run it. Okay, gonna submit it. I'm sure like people must have written better solutions with the space complexity. Time complexity is, I think this is the optimal solution. Space complexity, 2 pointers I already talked about. You guys can try it, but I will move forward because there are a lot more other problems to solve. Okay, time complexity will be big of n, and space complexity will be big of n. This can be brought down to, we can do better here if you like, but this is a good solution as well. All right, so I'm gonna go to AlgoYogi, mark this problem solved. We have one more easy problem, so clear digits. We'll solve that in the next video. All right, see you guys.